We have kind of a different one today. This is a Elo Touch Systems monitor for a point of sale system. I already have this thing apart. Here's the actual front digitizer touchscreen. This is for a local grocery store here in town. I already have this thing tore apart, as I mentioned. Here's the diffusers. The problem was these are both the problem was, in fact, the backlights. One backlight was working okay, the top backlight. The bottom backlight had like a pink glow to it. The monitor would turn on, display sort of like a pink image, and then shut off after a few seconds. The backlight, the monitor itself wouldn't shut off. I verified that by shining a flashlight in there, and there definitely was video, just no backlight. So what we're gonna do, the customer was gonna order a new monitor, new touchscreen monitor, and I told him to hold off. Give me about 2 days. Give me a day or two, and see if I can fix this for him before he goes ahead and orders it. I think new. He said there's something like $400 or $500. So I figured maybe we can save him some money and fix this thing for him. So what we have to do, I don't have any parts for this thing at all. But I do have a bunch of different kinds of LEDs, different sizes. So I think what we're going to do is convert this over from fluorescent backlights to LED backlights. So that's tricky and it's time consuming, and sort of doing them a favor over there by doing this, because it's kind of a complicated project here. But in any case, so what we have to do is we have to design two circuit boards. One to take the place of this backlight assembly. So the board has to go all the way across, and there has to be LEDs equally spaced all along that board, and we have to do the same exact thing on the other side. Okay. We also, of course, want to be careful with the LCD board here. It's very fragile. So anyway, if we equally space these LEDs, hopefully the diffuser will do its job and sort of make the whole thing just glow one brightness. So it won't be blotchy, is what I'm trying to say. Okay, so we're gonna go back, take one of these tube assemblies. We're going to measure it and design a board to take the place of this, and we'll be right back. This is what we came up with here. This is the LED. Let me scoot this over a little here. There. Okay, so this is the LED, and this is just, we printed out the PCB we designed just on paper, just for demonstration purposes. If you flip over the LED, if I can get it to flip over here. Okay. You see there's 3 contacts there. There's one on the left, one on the right, and one in the center. Now the contact in the center that's closest to the left there, that contact in the center and the contact on the left is both positive, plus. Contact in the center works as a heat sink. So what we did is we just made a fat trace, which is going to solder to the center in the left contact, and a thin trace, which is going to solder to the right. So here are the boards. These are just very quick and simple boards. These are nothing great here, but they'll get the job done. So it's going to work something like this, if you can imagine. Obviously it's flipped upside down, but they're going to be soldered in that orientation, just right side up, just like that. And what I'm thinking is, so we have 8 boards, So we're going to do 4 boards per side. The boards are roughly 3 inches, and this is roughly 12 inches here. 12 inches. So what I'm thinking is, let's see. So 1, 2, 3, 4. Something like that. And maybe we'll do an LED. Let's see. 1, 2, 3, 4, 5. So we gotta evenly space them is the problem. So now if we do 1 LED per strip, it might not be bright enough. And if we did 2 evenly spaced per strip, the 2 next to each other will be too close. So if we did an LED at the end, LED at the end, and then we did 1 here, 1 in the center. I don't know. Well, let's see. If we did them all an inch apart, I mean, that might work. Let's see. I think we're going to do it 2 inches apart. And I'm going to mark these all out, and we'll see where we're at from there. We have our boards finished here. What we're going to do is we're just going to solder each one of these together with some wire. So all these LEDs are all these LEDs. Let's see. Okay, so each board takes 3 volts max. So 3. 1, 2, 3, 4. 4 times 3 is 12. Okay. So what we're going to do, I think, is each one of these boards we're going to put in series. This is going to be in series with this and this and this. And then these two rows are going to be in parallel. The reason is there's 12 volts from the original stock backlight board, which is right there, that powers the high voltage circuits on that board. We don't care about the high voltage circuits, but we're going to steal the 12 volts off of that to power this new backlight, so we don't have to make a custom power supply for it. So we're going to do series parallel arrangement here. Okay, so positive from here is going to go to negative up here, etc., until we have a full series circuit. Then we're just going to hook these two up in parallel. And we're almost at the home stretch here. We're going to put the boards, install the boards in the cover there, the front cover. Test it. If it looks good, we're going to put everything together, test it again, and get it back to the customer. So let's start working on these boards. Just to sort of give a better idea of what we're doing here is, here's the boards. So to put this strip in series, we're going to come off the negative side of the first, number 1 strip. That's going to be our negative supply, or our ground, I'm sorry. Positive is going to connect to the negative of the next strip. Positive, negative the next strip. Positive, negative the next strip. And then positive is going to be our plus 12 volts. So that's 3 volts times 4 is 12 volts total. And then we're going to have a second strip just in parallel. So positive is going to go to this side of the positive, negative, negative. And that's how we're going to do it. So I'm going to go to positive to negative, positive to negative, positive to negative. Do that on both. And I think the first thing we're going to do, just to keep everything together, is take some Kapton tape, lay it right across this guy. So get some of my thin stuff here, thinnest I have. Check that out. Completely custom backlight strips. So in series parallel configuration, that's going to work beautiful. So I'm at 12 volts right now. I'm actually a little shy of 12 volts. You can actually make it a little brighter. That's 12 right there. That's very, very bright. Turn the lights off in here. So that's going to be beautiful. That's going to work better than stock. That's going to be 100 times better than these original stock bulbs. So he's going to get a nice, crisp display out of these. Beautiful. Jeez, works just perfect. Like I said, completely custom backlight strips. Nice, nice. All we have to do now is install them. What I'm probably going to do is add some more of that Captain tape. This stuff right here. It's high heat tape. Probably cover it more around the sides. Just make sure there's no shorts once we install it, because we are installing it into, actually no, it's a plastic case, but the metal cover goes on top, so we just want to make sure there's no shorts or anything like that. We're going to install this shortly. We're going to extend some of the wires, connect to the power supply board, and see what it looks like. Okay, so we're back here again with we've been bouncing around between the on-site jobs and everything. Anyway, it's actually nighttime now, but we're back in the shop. Just real quick, just wanted to give this a quick test. We did install the 2 custom backlight boards. We powered them on, put these in parallel, put them 12 volts. The light itself works. So now let's test the actual the monitor with the backlight on. So let's connect our positives together here. We're going to connect our grounds. There we go. Okay. We should fire up in 3, 2. Okay, so you see the backlight. Okay. Now you can see some LEDs here, probably because when we reinstalled it, again, this isn't designed for LED backlights, but actually when the video signal, when the actual monitor turns on and the video signal is present, you can't even see the illumination down here. It looks okay. So let's confirm that real quick. 3, 2, 1. Okay. And there we go. It's a glare. It's hard to see. Oh, and I hit everything. Just breaking stuff here. Okay. So it's kind of hard to see, but look at that. Beautiful. That was totally black initially. That backlight is doing its job. And see, you can't even see the bright spots on the bottom, so that's fine. That's perfectly fine. Awesome. Awesome. Completely custom backlight. We never worked on any of these units before. Elo Touch Systems, I guess, if that's how you pronounce it. And just to see, I can vary the voltage on my power supply and knock this right down. Let me turn the light off here for a quick sec so you can see a little better. And look at that. And I can turn it right down to nothing. Black. So we'll come up to about 12 volts. Right about there. That's max brightness. And we can even turn it down a bit. It doesn't have to be max brightness. There we go, guys. So we're not done yet. What we have to do now, let's turn this off. Turn the display off. Good. Let's unplug it. There is high voltage in the back of there. Okay. Okay. Let's flip this guy around now. So what we have to do now is we have to find, first of all, we got 12 volts coming into the original backlight board, but it seems to be constant 12 volts, which is really strange. But what we need to find is we need to find a 12 volt source that turns off when the monitor is not on, when the monitor is off. Once we do that, we can tap into a main 12-volt supply, use a MOSFET driver, and turn on our backlight with that trigger voltage. Similar to what we do with the, the fish finders, Lowrance units, and other units, same deal. So that's next on the agenda here for this. It's super late now. I gotta get home, so we'll pick back up on this, hopefully, for our last part, powering the backlight, tomorrow morning first thing. I'd like to get this off the bench. It's taken up my entire bench, this project, and it's been a couple days. I gotta clear this out and get work out. So we're gonna do that, and we'll get right back. We are back again for the last time. This has been a project. This has been a huge project, kind of just time consuming, really. But we did it. We fixed it. Check this out. Got to be careful. This is AC. This is hot side right here. It's on. Well, there's power plugged in. So check this out. This is the custom board we made. Okay, so we did away with the stock backlight board. We don't need it. We made a custom board right here. We made custom backlight LED boards on both sides, put LEDs in those. The wiring's coming over here. Come on over here. Series parallel circuit on both of those LED rails. And this is our power supply for the new backlight. So we have our trigger voltage coming in here. The trigger voltage is, we were looking around the board for a voltage level, a positive voltage level that's on when the device is on, but off when the device is off. And believe it or not, there's 12 volts all over this board, but it's constant. It's always on for some reason. I don't know why. It's just the way this unit is, I guess. We eventually found pin 1 of this connector is 5 volts, and it only turns on when the actual monitor is on itself. Awesome, right? Great. So ran that around, put it into our trigger side of our custom circuit board here. That basically just triggers the MOSFET. A couple little indicators. Green is power. So as long as there's 12 volts coming into the board itself, this should be green. So this is actually going to be green all the time when this guy is plugged into the wall. Again, just the way this monitor is designed, I guess. The yellow is our trigger voltage. Okay, so that's only going to be on when we're getting the 5 volts from over here. And when that's on, the backlight should be on. Okay, let's try it. I'm not sure what I have in that PC source. That's the PC we use for milling circuit boards and stuff like that. So it's just a Windows box. I'm going to turn this off so you can see that green LED. So we have power coming in. I'm going to press the power button on the monitor. Bam. There you go. Look at that. You can see we got some LEDs over here flashing. We have our trigger voltage. Well, that means the monitor should be working. Right? So let's click it again, turn it off. You can even see the backlight in there shining. Oh, let me get my little keyboard for that Windows box here. Just move the mouse around, make sure it's not hibernating there. Hibernate mode. Alright, let's flip this guy around carefully. Fingers crossed, guys. In 3, 2, 1. Can you see? I'm going to click it. There we go! This has been a long project, guys. Too long. Way too long. But we got it. Okay? It's working. If I could do it again, I'd probably design it with a little bit brighter LEDs, but I mean, it's working. You can see some LED a little bit brighter on the bottom, but you know what? The customer's going to be happy with this. We just saved them about $500 from buying a new one. Like I said, it's just a local store here in town, so I'm sure they'll appreciate the repair. Turn it back off. Oh, let's actually check it, right? So we're on right now. Okay. Let's make sure the backlight goes out. 3, 2, 1. Job done. Finally, job done. I'm going to get this thing put back together. Get this whole thing put back together. Get the touchscreen back on it. See this guy, touchscreen? Get that back on it and get this back to the customer and fix some fish finders. They're piling up. I got a bunch here. I got some down here. I got a bunch back here. We got to get some stuff done. So this has been a big, long project. Kind of a fun little project, but back to work, guys. Till next.